In this lesson, we're going to look at acceleration, and after this lesson, you should be able to compare the difference between displacement, velocity, and acceleration. First of all, the basic formula for acceleration is right here. The acceleration is nothing more than a change in a time period, and its unit is meters per second every second, or also noted as meters per second squared. Just remember, velocity was a changing displacement over time, so it was meters every second. Okay, three types of acceleration. First of all, you can be speeding up, getting faster and faster and faster. Second one, you can be slowing down, getting slower and slower and slower. And another one you can't forget about is changing direction, turning. Since velocity right here is a vector, it includes the magnitude. So the number could be getting bigger, the number could be getting smaller, or the direction. The direction also matters. The direction could be changing. So here's just a look, a visual of displacement. This would be a displacement of 5 meters in that direction. That's what it would look like, and that's it. It's done. 5 meters in that direction. Whereas velocity, you need a time as well. And here I just gave you a time of 3 seconds. So if you were traveling 5 meters per second, that means you're traveling 5 meters every second. So after 3 seconds, you would travel this total of 15 meters. And this would be a constant velocity here. Whereas acceleration means you're not going to have a constant velocity. You're going to be traveling faster by 5 meters per second. No, not just 5 meters every second, but you're going to be traveling faster by 5 meters per second every second. So this is what, and this wouldn't be like just all of a sudden they're traveling faster and all of a sudden they're traveling faster, but this would be a continuous speeding up right here if there was a constant acceleration. Here you're traveling 5 meters per second at the beginning. 1 second later, you're going to be traveling 10 meters per second. 1 second after that, you're going to be traveling 15 meters per second. So each of these times, you're going to be traveling a much greater displacement than if you were traveling a constant velocity the whole time. And this would just keep on going faster and faster and faster and faster. So another thing you should note also is that if the sign of V and A are the same, you're going to be accelerating or speeding up. If that sign is opposite, you're going to be decelerating or slowing down. And I'm going to explain this a little bit more. But really think of signs mathematically for direction. So if your velocity is in one direction and your acceleration is or you're changing velocities in the same direction, you're going to be speeding up, which makes a lot more sense. So here's your speeding up, getting faster and faster and faster, slowing down. I'm going to have this car coming from off the screen and slowing down to a stop. That's a deceleration. So in that last one, the car was going in a positive or right direction, but this change in velocity or acceleration was in a left direction, a negative direction. Okay, so let's just look at a couple examples of this a little closer. Here, the car is going to start with a velocity of 20 meters per second to the right, and it's also going to be speeding up to the right. Its acceleration is going to be in that same direction. So you go 20 to 30 to 40, and you keep on going faster and faster and faster. In this example, the car is going to start off going left, but it's also going to be changing that speed to the left, the velocity to the left, in 10 meters per second every second. So it's going to go from 20 meters per second to 30 meters per second, 40 meters per second. It's going to get faster and faster and faster, but in a reverse direction. So it's changing its velocity by 10 in the left direction. It's getting faster. Here, you're starting off at 40 meters per second to the right, but you're changing that by 10 meters per second every second. So subtract 10, you're going 30 meters per second. Subtract 10, you're going 20 meters per second. And this is what that would look like. Here's an example where you're going 40 meters per second to the left, but you're changing that in a positive direction. So you go from 40, you add 10, you get negative 30. You take negative 30, you add 10, you get negative 20. And that car would be slowing and slowing down until it would stop. So here's just two questions. If an object was traveling 50 meters per second east with an acceleration of 20 meters per second to the west, so it's changing to the west, is it accelerating or decelerating? And hopefully you said decelerating. If an object was traveling north, but its acceleration or its change in velocity was also to the north, it's going to be getting faster and faster and faster. And that one, 1 second later, would be going 70 meters per second to the north. And that would just keep on going because it's accelerating. Lastly, a common acceleration we have, if you throw an object up, gravity accelerates that object. It changes that object by 10 meters per second in a downward direction every second. So if I threw this ball up at 20 meters per second, 1 second later, it's going 10 meters per second. 2 seconds later, it's stopped. It's not changing. It still has that acceleration. It doesn't hover in the air. It's still going to have that acceleration. So after that, it's now the sign on the way up, the velocity was positive. the acceleration was negative. But at this point, the acceleration is still negative, but the velocity just turned. It's also negative. So what's going to happen? What's going to happen? It's going to start accelerating. So after that 0, it's going to be going on negative 10 or down 10 meters per second. And then 1 second later, it's going to be going on negative 20 meters per second, and that would continue. And so that's one of the common things that people have a little trouble with, seeing the difference between velocity and acceleration. And at the top of this flight right here, the acceleration never stopped. The velocity stopped. The acceleration, it keeps on changing that ball, and that's why it keeps on changing now in a downward direction. This starts happening.